So we were doing this naughty problem itself. Yeah, that's correct. So we'll continue with the problem practice. Now, to understand the concept of problem solving in the mechanics, especially the laws of motion, we deal with force, and every force we can resolve into components. So the idea is if we have a coplanar forces, it means they lie in the same plane. So when you resolve into components, they will either give you x or y. Because they are in the same plane. So they will have either x and y, maybe minus x plus y plus x, and like the sign can be different, but you end up being in the xy plane. So whenever we have any force in a given plane, and if the force is not aligned along one of the axes, like x or y, or maybe minus x or minus y, so there is a way to express it into the component form. And how we do it? We drop a perpendicular on the respective axis. Then the foot of the perpendicular will give you some point. We may say A, we may say B, and every vector which we represent graphically, if F is a force vector, then its modulus we write as just F. So you remove the arrow that represents the modulus, the length of the arrow. So imagine F as the length of the arrow, just like a normal triangle, a right angle triangle. What we are supposed to evaluate is the length of OA, and the length of OA we call Fx, because that's a projection on x-axis, or length of perpendicular on the x-axis. And similarly, the length OB we call YFY. This is the subscript notation. Okay, nothing more, nothing less. It is just a notation. Fx means F sub x. Sub means subscript. So for every alphabet, we all know the top is called, and this is bottom. So what do you say? This is called script. This is called subscript, and this is called superscript. So these are some notations that we regularly use. So fx means f, and x is the subscript. If it is not multiplied many times, so what happens, like when I write fx, it shouldn't be write like this. So no, it's not like that. It is f sub x. It's like subscript notation. In physics, it is very essential to learn this art of writing. It's very essential. Okay. So the fx refers to f cos theta, because we can easily identify by the triangle. Fx is f cos theta. F is the length of the vector. Theta is the angle of the vector with x-axis. Just a moment. So the x component we can write as f cos theta. Similarly, how we can write the y component? What will be the y component?
F sine theta.
Yeah, so it is f sine theta, and that has come basically from the fact that You take a vector f, you turn towards the y-axis. So you rotate the arrow, this arrow. So this is the arrow. Okay. So this is the arrow. This is the arrow. You turn this arrow towards the y-axis, and the angle, whatever you turn, you take the cos of that angle. That's the rule, thumb rule. So every component is only cos, but it looks like sine because of the value of angle. So, okay, of course you can remember as sine and cos, but the best way to remember is take a vector, okay, and turn towards the nearest axis, take the cos of that angle, and then put a plus and minus, and accordingly the arrow is pointing towards positive direction or negative direction. So that you can easily understand. For this example, if you take this arrow, the black arrow, and if you turn towards x-axis, the arrow is like this. So it's positive because this is matching with positive. Similarly, if you take the y component, the arrow is up, and therefore both are positive values. So this was the notion of taking the component. Now in mechanics, although it is not taught to you, and it will be taught to you in detail in the chapter of laws of motion, but still what I want all of you to learn is the basic of writing process. Okay. So as a revision or recap, I'll tell you what to remember. Okay. So there are some very standard practice you can say. The practice says that if I want to write a tension force, I will use T. Okay. I will use T. And if I have multiple tension, I'll use the subscript notation. So I like T1, T2, T3. So I can say Ti. So if you want to represent various values of tension in a various strings, the way to represent or denote will be Ti. Okay, I is not I. I means like you can choose 1, 2, 3, 4. So I may write I. Okay, you can belongs to positive integer. Yeah, that's a nice way of writing. Or you can say okay, positive. So similarly, to represent some other forces, we have a very well-defined subscript notation. So if you want to represent normal, so normal reaction is a force. And if you want to represent it, you can write as N with some subscript. Now again, the subscript will be 1, 2, 3, dot, dot, dot. Like depending on how many normal do you need. Okay. So the last is called the weight, and you will not come across something more than that as of now. So weight we write as mass multiplied by acceleration due to gravity. Okay. Or sometimes we just write at W, and you will not get multiple weights. So we deal with one mass at a one time, so we write just only one W. So now these are the basic notations which you need to know, and once you know this, then how to apply it. So in short, remember about tension. Just one fact you should remember about tension. T always act away from the mass. Okay, you consider. Okay. So it always act away from the mass you consider. All right. Similarly, how the n will act. So again, there is a very typical way of acting. So how the n will act? N will always push the object you consider. So whatever you consider, you just the normal will push it, so it will act that way. Gravity, we all know it will act towards our center. So now knowing that these forces will act this particular way, we can actually solve any problem of the naughty problem that we discussed in the last class. Okay. So let's take some example. So imagine we have a ceiling, and then we have two strings. So this is the first string. This is the second string, and we make some angle. Let's say this angle is maybe, it looks bigger angle. So let's say 53 degree. This angle I'm saying, okay, maybe 37 degree. Okay, that's quite okay. And there is a third string, and we are hanging a block from the third string. Now, what is given that the mass of the third string is m. So I hope you can see the knot. That's why we said the knotty problem. So this is the knot. So the knot is not, I mean, there's nothing there, but just we have a knot for understanding. We have something called knot. And now the idea is to find the tension develop in each three string. So if you
Sir,
look
what
at
is the mass of the block?
M is the mass. Okay, values are okay. Now you may be wondering, sir, you haven't written 2 kg, 3 kg, 4 kg. So in physics, generally we write things in symbol instead of number. Okay. And gradually we have to develop this habit of writing things in symbols. And the answer will be also expressed with the help of symbols. We refer to as symbolic answer. Okay. So because this is what you are going to face, so let's begin it here.
Sir,
Yes.
sir, by tension you mean force?
Yeah, tension making force.
So
So when I
first
say
let me draw
tension,
the x and y axis, no?
yeah. So yes, correct. So the moment you have a question like this, the first step is drawing the suitable axis. Okay. So of course the x and y is the most preferred one. So even we'll do the same. So we take the knot as the origin. That's what we started with in the last lecture. Okay. So the thumb rule is you take the knot as the origin and draw the suitable x and y axis. So I think this is better. So now we have drawn the origin, and we have drawn the suitable x and y axis. So let's call it x. Let's call it y. Now what is the next step? The next step is the knot is your object. So the first thing which we need to remember, the knot is our object, and therefore we draw the force on the knot, assuming it to be some hypothetical object. So you can imagine there is something there hypothetically present, and then try to show the force. Now, because the knot is attached some by three strings, the left, the right, and the bottom, so we should have three tension force, which we will write as T1, T2, T3. Okay. So this is how we start with. We first represent the tension force at the knot, which is what we have done here. T1, T2, T3. Okay. But we also have a suspended block. So when you consider a block, then what I said, the tension always acts away from the object you consider. So I started with the considering of the knot, and so I drew all these forces. But now I'm considering M, so I will draw a force like this. So now the bottom T3 is the force for the block, but the above T3 is for the knot. You should not get confused between the two. Okay. So I hope this is clear, guys.
Yes, sir.
Yeah. So T3, I have shown it twice, but one T3 is for the knot and other T3 is for the block of mass M. Okay. And because block is having mass, so gravity will pull in which direction?
Downward direction.
Correct. So the gravity will pull it downward. So you can draw an arrow representing the gravitational pull in the downward direction. And how we write it? What is the value of force? So there are two ways of writing. Either you represent W or mg. It is up to us to represent the way we want. In most of the options given in the question, you will find mg. So it is good idea to practice writing mg as a force instead of W. Okay. So now we'll consider two parts. So I will break it here. Now I have explained in the last lecture what is equilibrium, and we all know equilibrium means there is no acceleration. Okay, but here the in fact it is at rest, so we can say the net force is also zero, as well as acceleration is zero, as well as velocity is zero. All things are zero. So now if it is at equilibrium, then the net force. Okay, so now we have two objects. Object one is by default not. Okay, here we have this not. And object two by default not. This is the by consideration is the block. So now because we have two objects, so you have to write the net force equation for two times. Okay. So you have to write it separately. For the object, okay, we'll start with the object two. For block, can you see the force direction? So I hope you can see, and all forces are acting vertically. So I can just say for equilibrium, the net force in the y direction must be zero. X I'm not writing. Why? Because there is no force along x-axis. It's good not to write. So now if I write so you can see T3 is upward. So this is plus mg is downward. So we can write minus mg. And if you add up to, it must be zero, which will give you the value was T3 equals to mg. So now you can see that the T3, which was unknown, by this equation, we know its value. So we'll keep it ready for other calculations. So let's call it equation 1. Okay, so now we have one more object to consider, because that will bring the T1 and T2 into equation. So for object 1, that by default we take not. Can you guys tell me that for equilibrium, what are the conditions we must write? Should we write only Fy0 or Fx0, both?
Both.
Correct. So we must write Fx0 as well as summation of Fx, Fy equals to 0. So why we need these two equations? Obviously, T3 we have got, but we are still left with T1, T2. And looking at the diagram, we can clearly see there are some component along X, some component along Y. Both components are present. Therefore, for equilibrium, both component must be zero when we add together. So what is the next step? Because we know the origin, we know the X and Y axis, we know the arrow of the knot, the forces can be resolved along X axis, each force. And when you resolve along X axis, you're not supposed to consider the Y component. And similarly, when you resolve along the y-axis, you can ignore the x component. So because we have to write two equations, one is the fx equals to 0, okay, I can say a, and we have another equation called fy equals to 0, we can call b. So we have to deal with two equations. So let's begin one after the other. So what I want you guys to tell me, what should I write for fx? We'll equate it to 0 later on. But before that, what is summation fx meaning? What should I write here?
Sir, we have to add all the x components of each and every forces, which is
Yeah,
T1, T2, T3.
correct. And while writing it, we have to be careful with the sign as well. So we should understand is whether it is positive in sign or negative in sign. How we can do it? So I hope you have learned this how to do it. So can you start? I mean, who will tell me the T1 component along x-axis? What will be the component of T1 along the x-axis?
So it will be
T0.
30,
It will be
T1 cos 37 degree.
very good. So before we start resolving the component, it is good to represent all the angles. So now this angle, because of the alternative nature, this is also 37. And again, this angle is also 53. Okay. So now what you said is absolutely correct. It is T1 cos 37 degree. Okay. So now someone else must tell me what is the component of T2 along x-axis. It
Cos
means,
53 degrees.
yeah. And you have to be also telling me whether should I write plus or minus.
Minus
Very good. Because the arrow is left.
left hand side.
Yeah. So I should write T2 cos 53. Now, anyone who is not getting this particular expression, you can raise your hand. So I hope it is clear to all of you why we are writing like this. Now, what about T3? Will it have some component? Yes or no? Should we resolve T3 as well?
No, sir, it will be 0.
Correct. So T3 is along the y-axis. So when we have a force along any given axis, its perpendicular direction cannot have any component. So the force along y cannot have component along x. Similarly, the force along x cannot have component along y. In fact, any force cannot have component in any perpendicular direction. So that's the rule. You can remember it like that. Okay. So that's very good. And because we are solving equilibrium, we must equate to 0. So I hope this part is clear to all of you. And if this part is clear, then I must go to the next part. And I want some new volunteer because we have so many joinees. So I want someone else. Those who have answered already should give chance to other. So I want to write summation of Fi. Please help me out how to write it. So I may begin with Shishri can start the first part for T1.
Sir, first will be T1 cos 53 degree.
Very good. So T1 cos 53 is absolutely correct. And then I want someone else. Maybe you can answer the T2 part. So who wants to answer?
Sir, it's
Yeah.
cos 37 degree. Yeah.
The T2 cos
I mean
37.
T2 minus cos 32 degree, 37 degrees.
Okay. Once again, I think I got confused. Please tell me once again.
Sir, it's minus T2 cos 37 degree.
But my question is how you arrive at the conclusion that it will
Sorry,
be
plus.
yeah, plus. That's the right answer. So this is T2, or either you can say cos 37 or sine 53, both are same. Okay, very good. So we got T1 component and T2 component, but we are still left with T3. What about T3? So someone else must tell me the T3 value, which I should write here, and the sign as well. Anybody, anyone who has joined today? Yusuf and
Yes,
Parth,
sir.
if you have some idea, you guys can try.
Uh, T3 cos 90 degree.
T3, and you're taking the Y component. So what is the angle of T3 with Y axis? Can you see the angle?
90 degree. 180 degree. Sorry, 180.
Yeah, very good. So you can say that way also. That's also a nice way. You can say T3 cos 180 degree because that is angle with the y-axis, or you can simply say minus T3 because it is acting downward and making zero angle with negative negative y-axis. So that is also correct. Nothing wrong with it. And now what we are supposed to do is equate to zero. If you equate both the equation to zero separately, I hope you will get two equations and two variables because the T3 is known that you can use. So now what I want next is, can you guys tell me by solving these two equations on the right of the red line, what is the values of T1 and T2 in terms of mg? So I want all of you to solve these linear equations because that's one skill which you need to develop as we move along. So go ahead, guys. I will give you just 2 minutes to solve these equations. More than that. So just for the information, cos of 180 degree is -1. So we also write this as cos pi, and in general, cos odd multiple of pi is minus. Cos even multiple of pi is 1.
Sir, there is a question. Can I ask?
Yes, of course you can.
Okay, one second.
So the question is related to this or something else?
Further, it is related to vectors only.
Okay.
Question is the sum of magnitude of two
Mhm.
forces acting at a point is 16 Newton.
Okay.
If the resultant is normal to the smaller force
Mhm.
and has a magnitude of 8 Newton, then
Okay.
the forces are four options are there: 6 Newton and 10 Newton, 8 Newton and 8 Newton, 4 Newton and 12 Newton, and 2 Newton and 4 Newton.
Yeah. So if you remember that when we have two vectors and if the resultant is perpendicular to one of them, So if you remember, there was a diagram which I drew. So I will not draw it here. I'll draw on the next page.
Yes.
So the answer was very pretty easy. If we have A and B, any two vector, and if the resultant is perpendicular to any one vector, let's call it A, then the modulus of R turns out to be under root of B square minus A square. Okay. So this was the answer. And what is given to you that the sum of the vectors, right? So the sum of vectors is given how much? 16 Newton.
16 Newton.
The resultant of two, right?
Yes.
No, you are not right, reading it correctly. So I think the sum of the force is given as a vector or as a magnitude.
Magnitude.
Yeah, exactly. That's what I'm asking. So the two sum is, you can think as what is given to you that A plus B is 16. Okay. And
Yes.
what is resultant given? The magnitude of resultant is 8.
8 Newton.
8. So 8 is equals to under root of B square minus A square. And therefore, B square minus A square is equals to how much? 64. This you can write as B minus A into B plus A is equals to 64. But we know that B plus A is 16. If we solve, we get 4. So now we have two equations, A plus B, and better I will write B minus A, B plus A. So B plus A is 16, B minus A is 4. So these two linear equations we can solve by adding. So you'll get 2B equals to 20. So B gives you 10. And because B is 10, so I think finding A is not difficult. So what is
6.
A? A will be?
6 Newton. 6 Newton.
So these are the two answers. Okay.
Yes, sir.
Okay. 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 Is this done? The first question which I gave, is this
Yes,
done?
sir, done.
Very good.
Yes, sir, done.
So can you tell me what is the T1 value after solving? If you all have
mg
all
sine
you have got
mg sine 53 cos 53.
mg sine 53 cos like this, you need to say like this.
Yes, sir.
Okay. And what about T2?
T2 I got mg sine square 53.
Okay. So okay. So the first question is giving you T1 cos 37 is T2 cos 53. So that you could have substituted the value also. So, okay, if you do not remember the value, these are very famous value. This is called 3, 4, 5 triangle. So now we should know the 3, 4, 5 triangle because it is very common in physics. So what is this triangle? If you draw a right angle triangle with two of its sides as 3 and 4 and 5, so it will form a right angle because this is called the Pythagorean triplet. So we have very famous triplets like a 5, 12, 13, right? And we have 3, 4, 5, 6, 8, 10. So these all are very famous triplets, and we are supposed to remember the answer. This is 4 because this is looks 4. This is 3. This will be definitely 5, and this is the smallest angle, so we call it 37. This is 53. So now, because you're not supposed to remember the answer, now by looking at that triangle, can you tell me what is cos 37?
It is 4 by 5.
Correct. So now what you can do is use this triangle, and every time you're solving question, you can draw and then substitute the value first. So now you can tell me what are the values of T1, T2. Okay, in simplified way. I don't want cos and sine in my expression. We use
Yes,
sine
sir.
and cos only when the theta is unknown. Yeah, tell me.
Sir, for T1 I got 12 mg by 5.
Okay, so T1 you got 12 mg5. Can someone else will verify the same? Maybe Srishti, can you verify the same? Is it coming same?
Sir, didn't call.
Who else is getting the same answer? Hello, hello.
No, sir. I didn't get.
Okay. So let me solve this question. So how to solve this? The first expression, the fx part, if I bring it here, it will give you t1 multiplied with cos 37 is how much? 4 by 5 minus t2, 3 by 5 is 0. So the 4t1 is 3t2. So that is what we have. We can just keep it, maybe calling equation 2. And if I call this expression, so what I'll get is t1 and cos 53 will be how much? 3 by 5, right? Yeah, I should be right. 3 by 5 plus t2 4 by 5 and then t3 minus t3. So can I substitute minus is there minus just directly mg? And if I do so, what I'll get? I'll get 3t1 plus 4t2 equals to 5 mg. This is what I got after rearranging. I can calling it equation 3. So now we have the two equations, and now it's up to us to just solve. So I'll just put it separately.
So can you show the previous page once?
Just a minute. Let me just put it separately. So that's the solution for someone. Yeah. Yes. So now we have two equations. I don't think that you guys are having this experience of solving the linear equations. So you all should get the answer. So 3t1 plus 4t2, which is 4 by 3t1, which is, yeah. So I think 12 by 5 was the right answer for t1. Just
And for T2, I got 4 by 5 mg.
you're saying for t2 or t1?
T2.
T2, 4 by 5 mg.
Yeah, sir.
Okay. So can someone else also confirm? Because see, now it's only up to solving the question. And I think this is where your own mathematical skills comes. Physics has no relation to this solving question 2 and 3. So, okay, you all
Sir,
should
I
come up.
got it.
Yeah.
Sir, same answer.
So T1 is finally the final answer. T1 is you're getting this one,
So 12 by 5, yes.
and T2 as right,
Yes, sir.
and T3 as MG. All right. So now you have practiced a question in which the angle was given. So now what I'll do is I'll try to make it a slightly difficult. It's the same question, but you won't get any angle value. Okay. So what will
Sir,
get?
I have just one doubt in the question. Can you show the previous
Yeah.
page?
So you want to see the previous question?
Oh, yes, sir, I have a doubt in that. Sir, what is that? I mean, so, sir, about mass of the block, weight of the block, sir.
So
There are two T3s.
M is the mass.
Sir, no, there are two T3s. One is acting downward and one is acting upward.
Correct. So at the tension,
One is normal.
no. When you attach a rope, so rope will have two ends, okay? Or the string will have two ends. And what you need to realize, which of course you will not realize now. So as of now, I am saying that you just solve it mechanically. So I have drawn two T3 because we have two blocks, two objects. So if you look at this portion of the whiteboard, so I have considered object one as not. This is the virtual not. Then nothing is there, but I'm still calling it object. Okay. And I have taken the block as the other object. Okay, so I have considered two objects, and now if you go back to the last page, so T always act away from the mass you consider. In fact, I should write object you consider. Okay, so I can say, okay, let me remove this and call it object. That will be better. Yeah, so I'm written this object you consider here. So the T always act away from the object you consider. So what you consider as an object, the tension must act away. So here when I am considering the knot as my object, T is down, but the moment I consider M as my object, Tx up, because T, called the tension force, always act away from the object you consider. Okay. So now imagine you're hanging from some object. Let's say you are hanging from some ceiling or maybe some horizontal rod. Just imagine. So if you observe carefully, you're trying to pull the rod down, but the rod is trying to pull you up, isn't it?
Yes, sir.
So imagine you're hanging from a rope, a thick rope. So what do you think? The rope will pull you up or push you down?
Pull me up.
Correct. And what you are doing? Are you pulling the rope down or pulling the rope up?
Pulling rope down.
Correct. It means the same rope. The moment I switch the object, the direction changes, right? So when I'm considering you as the object, the tension is up. But the moment I consider the rope as the object, the tension is down. So the idea is tension act at the same time in two different directions, or in fact two opposite directions for the ends we consider of the same rope. Okay. So tension always pulls, and of course this will be taken care of in the chapter of laws of motion. Now, present idea is not to learn the laws of motion, but to understand how to apply the concept of component of vectors. Okay. So if you are comfortable with the component part, that is the battle is won. Okay. The other way of solving this problem is the tabular method, which okay, it's good to start with, but I will not encourage the tabular method as a okay when you grow old in this solving problem, that you won't consider as a very good practice, at least for JEE examination. But if you look for the go back to the US universities, they only use the tabular method. And why they use? There is a reason behind this. When they solve problem, they solve the real problem. Like they will have very bad values, and they need calculator to calculate everything. So because they need lots of calculation using calculator, and they give values like that. So it's good to write in tabular form so that you can do the computation easily. In competition like JEE, we don't get such bad values. Rather, we get symbolic answers, and therefore it's good practice to just solve like linear equations instead of putting into tabular method. Okay. Okay. So what I'm going to do is, if you have understood the previous question, this should not be a
Sir,
difficult.
that simultaneous equation can you solve?
Okay. So you want me to solve equation?
I'm not able to match that answer.
Okay. So this is the first equation. Okay. So can you recall the equation? This is the first equation. So you're just trying to plug one value in the other and solve it. So, okay.
Yeah, sir, I did that.
Okay, no problem. So 3T1 plus 4T2. 3T1 plus 4T2 is 5 mg. And the other one was how much? 4T1 is 3T2. Okay. So T1 is how much?
So that we can write T1 is equal to 3 by 42.
Correct. Now can you substitute here? 3 3T2 by 4 plus 4T2 is 5. And so 9T2 plus 16T2 upon 4 is 5. So the 25 T2 is 20 mg. So 5, 4. So T2 is 4 mg by 5. Okay. Okay. In US, they don't cut like this. So in US, if they will teach you, even at a very high level, they will act like this. So they will say multiplying. So they have this equation at 3, 3, 3. They see how they will teach you. It's so boring. I don't know how to teach. But okay. So multiplying both sides with 4. Oh, that's nice. This is what they will do. Why they will multiply with 4? Because they want to get rid of the 4 in the denominator. So they will multiply both sides. So they like
Yeah, sir, I understood. I made a mistake
4.
starting me only.
Anyway, so I expect all of you to be good with calculation because
Sir,
in the beginning, yeah, I
so
may
sir,
solve
just
it. I will not solve afterwards. Yes, tell me.
the value which we have got for T2, that means the second rope,
Yeah,
the
correct.
T2 rope. So the
Yes,
tension on that rope is equals to 4 into mg upon 5.
correct, correct, correct. So that is a
And
force,
similarly,
and that force will remain throughout the extinction. Okay,
okay, and similarly we can find out T1 also.
of course, because we have the relation we can find. So in fact, let's do it and finish this off. So T1 is almost 3 by 4 into T2, which is 4 mg by 5. So I think someone told me 12. That looks incorrect. So answer is 3 mg by 5. This is the incorrect answer. Someone told me 12. I mean, I don't know who told me, but someone told me. Anyway, nevertheless. So we have this answer, T1, T2, and I hope it's not difficult. Okay. So now let's solve this question. Maybe slightly more mathematically rigorous, but it's a nice problem. So I want to see that how you react to symbols. The problem is very much similar, but the only twist is that we don't have angle. So what we have is alpha is the first angle, beta is the second. And again, what we are supposed to find? The same thing, T1, T2, and T3. So the
So we can
T1,
solve
T2,
this.
T3. Pardon? So anyone interested in solving this question?
Yes, sir.
So please go ahead, and the answer will be in terms of alpha and beta, and you will find it's more rigorous. Now, this is the beginning of your journey towards the symbolic answer. So far till class 10th, you have habit of doing the calculation with numbers, but now we have to develop the calculation with symbols. Okay. So go ahead, guys, and I wish, that you all should get the answer. So I'm waiting. You may take few more minutes. That's totally okay. Are you guys solving? Just you can
Yes,
confirm.
sir.
Yes, sir.
Okay, go ahead. Shishi, you are there?
Yes.
Yeah. So do solve. The last time when I asked your name, you were not responding, so I thought you must have left the lecture.
Okay, I got
Sir,
disconnected.
90 minus beta, is it alpha?
90 minus
beta.
beta. No, it's not 90. So here the third angle is not 90. You cannot say it's 90. But what you know that the third angle is 180 minus alpha plus beta, because the sum of the angle is 180. That's what you know. Okay, anyway, that's why I'm saying it's not very easy. And we will learn solving this question again at the end of the chapter. So there are two methods of solving the question. One is called the component method, another is the like something advanced, the sine law method. So we'll do it again at the end of the chapter. Same question, and you can do in one line. So that's like a magic. But we have to learn all the basics along with the magics. So I know that you will not be comfortable with this problem because
Sir, no
everything is,
issue.
but you have to learn this anyhow. You have to learn this. This is the way to go forward. So I can help you with some of the steps. You can, this is alternative.
Sir, just I have one question, sir.
Yes,
Doubt.
tell me.
Sir, for the y component of the T3, sir, should I write minus T3?
Yeah, just at minus. Correct. So you have to proceed the same fashion, like you have the knot, you have the mass. So for knot as an object, you know what to do. For mass and an object, you know what to do. And that will give you two set of equations. And if you follow the steps that we did in the last problem, you will end up getting the answer. Although it will be slightly difficult in terms of appearance, maybe you will feel that this is a very strange way of writing the answer, but that's totally okay.
Sir, I got the answer, but it is in cos and sine. Is it okay?
Yeah, that's totally okay.
Sir, can I say the answer?
Yeah, please go ahead.
T1 equals to mg cos beta divided by sine alpha plus beta.
Very good, very good. So T1 is actually that answer. So T1 is
The mg cos beta
mg cos beta.
divided by sine alpha plus beta.
I think that's perfect answer. Very good. Wonderfully done.
And so T2 I got
And T2 will be this change of beta will become alpha.
alpha, yeah.
So how many of you got this answer? Anybody else who got this answer?
Sir, I got half only. Till mg cos theta.
Very good. And upon you're not getting.
No, sir, at that little mistakes.
Okay, no problem. So okay, I will anyway solve. But I want you guys to try, okay, at least try to copy the method which we did for the last problem, and you will get some weird expression. Actually, sin
Sir,
alpha.
I got two expressions. I mean,
So yeah, you will
all
not get.
expressions.
You will get like this: sin alpha cos beta plus cos alpha sin beta, and that will become sin alpha plus beta. So your actual expression will be this long, and that you need to realize that this expression is of a trigonometric formula, or you can say identity. So this formula is something which will minimize the answer into this format. So go ahead, guys, and let's see if
Sir,
you're
I
getting.
got three equations that T2 cos beta is equal to T1 cos alpha.
Very good. That's first.
Then,
That's correct. Correct.
then I got T3 is equal to mg.
That's correct. Correct.
And the last equation I got uh, uh, T2 cos 90 minus beta plus
Yeah.
T1 cos 90 minus alpha
Yeah.
minus T3 is equal to 0.
Correct. So all are correct. So you're
Yeah, sir, I also got the same thing.
very good. So I think equation wise, you all are getting the correct equation. So I think now that is skill you have to develop how to solve equation. Okay. So uh, T1 cos alpha was T2 cos beta. Okay. I'll write directly T3 is mg because I know this answer. So I will write T1 sine alpha because cos 90 minus alpha is sine. T2 sine beta is mg. And then I'll substitute either one of them. Okay, as you wish. What do you want to substitute? Tell me. So let's find T1 first. So T2 we can write as T1 cos alpha divided by cos beta multiplied by sine beta is mg. So now this part is okay, then I will proceed. Shall I? Are you okay with this part? I have taken these two
Yes, sir.
questions. The third part. And now it's up to you. You can just take LCM and we are good to go. So we have cos alpha sine beta divided by cos beta is mg. And now you know how to take the LCM and all. So that's also very important to know the LCM, HCF, fractions.
Sir, I didn't substitute my value of mg in the T3 so that's why.
Okay. So nevertheless, we are learning it. So it's totally okay to commit mistake, do some stupid things. This is part of learning. When we learn, we make mistakes. If you're not learning, you're not making a mistake. So when you don't make a mistake, it means you're not learning at all. All right. So okay, we got the T1. Can you just proceed to get the T2 as well? You can directly use this formula to get the T2 directly. And you must do it. Like it's not like okay, you can copy and paste from the my.
Sir, instead of that cos beta, there will cos alpha because cos beta will cut and that cos alpha will remain there.
Very good. Okay, so we have done one kind of problem. I won't say we have done all types of problem, but I'll give you some new problem to solve. So this is again a easy problem, a very famous one from the laws of motion chapter. So I will mention name of the force. You just need to solve it. Okay. So I'm drawing the FBD, the free body diagram. You're not supposed to bother about it, how it has come, why it has come. It is there, and you're supposed to just solve. So and this problem is also very essential to learn because it will teach you something new today. So let's see what it will teach. So we have block of mass m, and it is at rest. It is at rest under the action of three forces. Of course, there are three forces acting. The first force acting is
Normal.
normal. Yeah. So it is acting this way. So what we do is we just represent at the only one point. So it's acting upward. Although normally it is acting like this. This is the right way to represent. But we'll show tail to tail representation. Okay. So tail to tail representation is easy to deal with. So we put a tail here. This is called force N. Now why N? It's normal. Gravity will act as well. It will act vertically down towards the earth. So don't write many students draw like this, like this, like this. No, it's vertically down. So gravity will act down, means down always. And there is one more force which I am introducing here, that is called friction. So
Friction.
yeah, if you don't know, don't worry about it. But I am calling by the name F. F stands for friction. It doesn't matter what it means. What matters is can you resolve and can you solve it. So now
Yes, sir.
you're supposed to find F value and N value in terms of mg and theta. So can you guys try this?
Yes, sir.
Yes, sir.
Okay, please go ahead. So block is uh, so this won't be a difficult job, and it's a really simple and nice problem. So now you may be wondering that how to assume the x and y axis. Can you guys tell me some hint about the x and y axis?
The normal,
Yes, sir. The
perpendicular
normal will be
normal
y-axis and the friction line which I have drawn
This is what I
is
was
the
is the
x-axis.
x-axis.
very good. So here the coordinate axis, the choice of the axis is very important, and one must choose suitably to write the answers easily. Okay, so please guys go ahead. So I hope you'll get the answer easily this time.
Sir, force is oh, no.
So you tell
Normal
me.
force is
And our force is
mg cos theta.
very good, very good. Correct. So normal force is mg cos theta is right. And what about the F?
Sir, I got same mg cos theta.
No, both cannot be same.
mg sin theta.
Is it a guess?
Yes.
Yeah, it's a guess, but that's the right answer. That's the right answer. But can you guys solve it? So these are the answers, but you can solve it. It's not difficult.
Sir, wait, sir, solving, sir. So my net was not there, so I couldn't see the question actually.
Okay, no problem. I am there. I am there. I am waiting for all of you guys. You guys are putting fabulous effort. I am really happy. So I can give some time. So
Oh, sir, I got it. MG Saita.
very good. So now what you need to calculate is the angle is very important. So what is this angle? Okay, if you can get this angle, I think the job is done. What is
Theta,
this?
theta.
Yeah, exactly. This is theta. And because this is theta, so I think resolving the force mg is pretty easy. So what is the component of mg along the y-axis? The downward one, the down axis?
It will be, sir, sorry, minus
No,
mg
just
sin
value.
theta.
Minus is there, but okay, if we represent it, okay, yeah, that's correct. So you just do the way you are doing. So
Sir, I considered theta same for both conditions, so that's why I got cos theta for both. Then I
okay,
90 minus theta, so it will be sin theta. So
yeah, correct.
sin.
Very good. So of course, this is 90 because this is the whole is 90. So of course, if you know one angle, the other will be like this. So what are the equations? If I want to write the equation, the force index is 0, and that means F minus mg sin theta equals to 0, and that's why F is mg. And similarly, force in y is 0, so n minus mg cos theta. N is mg. Okay, very good. So anyone to see? Anyone wants to see this answer? Shall we move to the next page?
So wait, so only 1 second. Sir, done.
Okay, very good. So next column. What is this next column? This is the next column. Okay. So a heavy cylinder is supported like this. Okay, so we need one more support of this. So you can see that these are the fixed, the blocks are fixed, so support. This cannot move. And you can see that it's holding a cylinder of mass m. And if you draw the center, which you should draw in fact, if you join the edge at which it is touching, you could draw a vertical line. Okay, now tell me what you want. A value should I give you or a symbol as
Symbol.
angle?
It's a symbol.
It's a symbol.
Okay, very good. Alpha
Sir, m is the mass of the cylinder.
Correct. M is the mass center. So because it is touching, so it will experience normal. So the normal, how it acts perpendicular. So the one normal is acting this way. In fact, I should draw. Okay, I'm drawing here. The rest you can draw further. So I want you guys to draw the actual diagram which you need to solve. What I'm drawing is the normal edge. That's it. This, so there are two normal. I am, because we have two normal, so I will name as N1, N2, and the gravity we know is N. So now what you are supposed to solve when find is N1, N2. So find N1 and can you guys try this?
Yes, sir.
Yes, sir.
Okay, go ahead.
Sir, N1 and N2 are acting upwards, right?
Yeah. So you can extend that line further and you can make it co-initial vectors. You know how to make co-initial? So take the
Yeah, sir.
center, yeah, take the center of the cylinder as the origin. That's the idea. And then draw the relevant lines to solve.
Sir, I got
Yeah.
N1 as mg cos beta by sin alpha plus beta, N2 mg cos alpha by uh, sin alpha plus beta. and N3 is mg, which is N3 and
No,
mg.
no, there is no N3 here. Here we have only N1. We don't have third force.
Okay, sir. Sir,
Because
mg,
mg itself is third force.
yeah, sir, that. So I took it as N3.
No, how you can took N3? That's not even present. The gravity is applied by the Earth. So there is no contact here.
Okay, sir.
Okay, so you have to be careful because what you're trying to do is replicating the previous problem. So you try to maintain the procedure exactly same, which is also not a good idea. So okay, so if you extend, okay, if you draw the coordinate axis
Sir,
here,
the answer last step. Sir.
Sir, can I say my answer?
yeah.
Sir, mg cos beta by sin alpha plus beta n1
Mm-hmm.
and n2 mg cos alpha divided by sin alpha plus beta.
That should be the right answer. That should be the right answer. So the N1, you can extend this line further here if you want to make it as co-initial. And so you can make N2 like this. And Mg is anyway downward, so that's okay.
Sir, I got the answer for N1.
Where
Sir, N1 is minus mg sin beta upon sin alpha plus beta.
but why minus? You're writing the value. If you solve, it should be positive.
Sir, minus is coming, sir, because sir, for the y components, it is minus n1 cos alpha minus n2 cos beta
Why
minus
minus?
mg
So
is
why
equal
why
to 0.
why value is plus? Why it is minus? Upward is plus, no?
Sir, I considered the normals down only at
Normal
therefore
is
it
actually
is
upward. Okay, maybe that is a mistake. So normal is pushing. It will push. So what you need to also remember, normal always push the object you consider. Okay. Okay. Not okay. Okay.
sir, then my rest of the answer is correct or wrong?
Yeah. So your procedure is correct. It's one misunderstanding. So, but if you rectify this, I think you get the right answer. So the equation that you should get is N1 cos alpha plus N2 cos beta equals to mg, and N1 sin alpha, which is plus minus N2 sin beta equals to 0.
Sir, I got this same
If
equation.
the equations are same, then you will get the right answer. So are you getting these equations?
Yeah,
Yes,
sir.
sir, same equations.
So then I think absolutely you should get the same answer. So the N1 is coming out to how much? Mg.
Sin beta
Sir,
by
mg
sin alpha
sin
plus
beta
beta.
upon sin alpha plus
Yeah,
beta.
yeah. Sin beta on.
Sin alpha plus beta.
Okay, that looks fine. Okay. So we have these answers. N1 and N2. Okay, so we have done enough practice, and actually we can move further in the course like a vector. So I will put a stop to this question because the idea was not to teach you laws of motion. The idea is to just give you the basic of the application of component, like why we resolve vector. So we resolve vectors so that we can solve things like that. We resolve vectors so that we can add them together. We resolve vectors so that we can, analyze it better. So the purpose of a resolution vector should be clear by these examples. Okay, so that was the motivation behind giving these problems, and we will actually see in detail. Okay, so we'll see all these things again back in the next chapter of laws of motion. Okay. So do not worry about the same. In the chapter of laws of motion, we are going to come across these questions in a large number, a very large number, in fact. So keep in mind, guys, the component was the idea, was the motivation behind these problems. And these problems are not the primary goal. Okay. So if you are okay with the component of vectors, if you know how to take the components, then the purpose is fulfilled. So I hope that you all are able to find the component at least, right?
Sir, sir, this
Yeah.
is the last point of vectors. I mean, last part
Yes. Yes.
and the new chapter,
No, not a new chapter. We will have a new topic actually. The vector is
but
really long, big chapter, so we have to
it
consider.
will be a vector only.
Yes, it will vector. Vector is not going to end now. Okay, so what we can do next is called a resolution of position vector
Sir, what is meaning of resolution?
component. When you resolve, when you resolve into component, that's called resolution. So resolution of position vector. Okay, first of all, I will define. Have I defined the position vector? Yeah, I have defined. So resolution of position
Yes.
vector in 3D. So resolution means component only. Okay. So we have seen the component in 2 dimensions, and we were very happy to resolve along x-axis and y-axis, and we proceeded to get the answer. But what if we have the 3-dimensional vector? It means the arrow is not confined in one of the plane, so it is neither part of xy plane nor yz nor zx. It is somewhere between. So when it is somewhere between, how are we going to resolve? Okay. And how are we going to represent the direction? So if you remember, we were able to represent the direction in a plane with the help of only one angle, theta. But what if the vector is in 3D and we wish to represent the direction? Now the theta will not be sufficient. We need something more than that. And that is the motivation behind learning the position vector in 3 dimensions. So to begin with, what I'll do is I'll draw one coordinate system. So I'm drawing x, y, and z. Okay, so let me draw this x-axis, y-axis, and z-axis. Now the z-axis I cannot draw because it is perpendicular to the my whiteboard and it is towards me. So to draw the same, I will draw a tilted line, something like this. And you have to believe that it is the green line is pointed towards you. Okay. So this is what you have to believe because I have no choice. Yeah, I have no choice. In fact, I have no choice. Okay. So to make it more 3D effect. Okay, let me maybe I can do this. I will complete one cube, in fact cuboid. This may give you some 3D appeal. Okay, this can be. So you can see that we have drawn a cube and sorry, cuboid, and the side of the cuboids are okay. We have 4 parallel sides. Every side will have 4 parts which are parallel. So what I'm going to say is, I will say this is x-axis. Y-axis and z-axis. And this is the origin. So how we put the nomenclature? Because we have a 3-dimensional world, so we have to represent every coordinate by a tuple of 3 numbers. So we write x, comma, y, comma, z. So every point in a 3-dimensional space we write as x, y, z, x, y, z. So if I consider this point, this is a part of xy plane. So how we write it? So you can write y x, y is 0, z is 0, like this. And if I want to write this point, I can write as 0, y, 0. If I want to write this point, so what we can write? Can you guys guess?
Sir, it's
0, 0, 0, 0, 0, 0, 0.
Very good. So can you tell me this point?
sir, it's x comma 0 comma z.
Very good. Okay, so now what about this point?
Sir, it's x comma y comma
Y.
0.
Very good. What about this point?
Sir, it's x comma y. Sir, it's in it is lying in the z. X y z.
Yeah, it's in YZ. It is YZ plane.
Y, Z. X will be negative.
Acha, it's y.
Zero.
X will be 0 because it's in
Sir,
the
0
YZ.
y z.
Okay, so finally, what is this point?
X, comma, Y,
That's it.
comma, Z.
That's correct. So it is x comma y comma z. So now we know how to represent the coordinate for a 3-dimensional world. So if something lies in the xy plane, the z coordinate will be 0, and
Sir?
so yes,
Sir, that coordinate X, comma, Y, comma, Z, the last one.
yes.
That Z will not come. 0 will come. No, X, comma, Y, comma, 0, because it is lying on the x-axis.
No, it is not on the x-axis. It is like away from the stream.
Above the
last,
X, comma, 0, comma, 0.
no, it's not above. Okay, I mean this is 3 dimension. You have to imagine 3D.
This one.
3D. Yeah, it is like this. It's like this. I'll do like this. Imagine this is the point, and if you drop a perpendicular, it is somewhere here. Okay,
Yes, sir.
and if you draw further perpendicular on the x-axis, it is here, and it is here. Okay, and if you
Yes, sir.
draw perpendicular, I'll draw a line here. If you draw perpendicular on the y-axis, it is something like this. So this is 3D, and so it's difficult to imagine. Okay. And
Okay, okay.
now if you try to complete, it will become a cube like this. Like this. Like this. So
This,
of course it demands some more visualization, and this is what we have drawn. Okay, so I have drawn in the other way.
yes,
Okay,
yes, yes, sir.
so the point is not in the plane; it is in three-dimensional space. Okay, so the
Yes,
point P, I will call this as point P, and the arrow which will join the point P to the origin will be my position vector. This is called R in 3D. This is the R vector in 3 dimension. Okay. I think the
yes,
many
sir.
are losing the network connection. Yeah. Right. Okay. Anyway, so this is the position vector in 3 dimension, and I want to express this in terms of x, y, and z coordinate. Okay. So of course,
So
what
it
I
would
will
be
use.
represented solid angle.
No. There is a solid here. We'll do it very simple. Okay. Now, the idea of angle is very like basic in your brain. So what you know is angle, but you have to also realize the notion of angle which you carry in your brain is angle in a plane. Okay. And because the angle is in a plane, so we need to first define the plane in which you want to find the angle. So when I draw r vector like this, then I cannot define just one plane for R. So if you look at the X, Y, and Z axis and the R axis, in fact, R is also, you can say, some axis. So are they lying in the same plane? The answer is obviously not. Okay. So it's difficult to understand the plane of R. But when I say, can you see the plane? Can you see the plane in which the Y axis and the R axis lies? Can you see that? Can you imagine a plane in which we have just R and Y axis, the two axes, R and Y? Can you see that?
Sir, yes, sir.
So what I'll do is I will try to show you one in a graph, 3D graph, the way I normally do. So give me some moment. I'll show you something interesting here. Just a moment. Um, no, no. Just a moment. It's taking some more time, but this 3D picture will help you in realizing something. Yeah. Yeah. Then good to go. Yes. So now. Okay. Okay, can you guys see this screen now? I have shared one screen. Can you guys see?
Yes,
Hello,
sir.
hello.
Yes,
Yeah.
sir. Yes, sir.
Okay, so now you can see that I have drawn a plane in three-dimensional space. Okay, so you can see that this is a plane. Okay, you can see from various angles. Okay, I think this angle is better, right? Yeah, this is better.
Sir,
Yes.
whatever you have taught till now of vectors, if you
Hmm.
want to recall it or we have to revise it, then in which book we will get all these?
Unfortunately, I mean, no book will cover this way. So they will only cover the basic idea of what is vector, what is resolution vector, and something very basic. Okay. So the problems they will not take in chapter vector. So for this vector chapter, there is no book which is sufficient. So probably you can go for the mathematics vector book. Okay. And along with physics book. So if you want more on this, I will recommend one book which is really good, which is called the University Physics. So if you want
University
to,
physics.
yeah, by C.S. Jimansky. It's a really good book, and if you want, you can buy it.
Okay.
Okay, so look at this. So what is the idea of vectors in a plane? So when I say vectors, so I can draw a line like this. This is my p vector, and the y-axis, and maybe I can say this is the p point. This makes some angle. You can see. Can you see this angle?
Yes, sir.
Yeah. So this is called the angle between the y-axis and the p and the r vector. So what I'll do is I'll do something here. Okay, maybe. Okay. So let me do some changes here. Maybe minus. Okay, maybe minus x plus. So you can see the plane has changed angle, right? I can keep on changing the plane angle by changing the value. Maybe I can put it to 3. Maybe this is plus. So I can put it minus. So you can keep on changing the plane, and we can take care of the x-axis, y-axis, and all axis. What is the idea? The idea is the r vector which you draw. When you draw the r vector, this r vector, if you can draw in various plane. So we draw in one plane, you can draw in other plane, and I may draw something like this. Just a minute. So I can add x equals to, yeah. So you can see the plane can go this way also. You can do a plane this way also. There are various regions in which we can draw the plane, and for every axis and the p vector, we can have actually how many planes? How many planes we can have with each pair of given vector r and x, y, z? Can you guess the plane? Three planes, correct. So okay, that is the motivation behind this representation. So I'll go back to my own screen. Okay, so the idea is what we need to realize that we have three different planes. Okay. So I may show one of the plane and rest you can guess because it's difficult to draw all this three-dimensionally. I'm trying to show you one plane which is this r vector and the y-axis symmetry, because that is easy to visualize on this on this whiteboard. So that's what I'm doing. And then rest you can imagine. So okay, still it's difficult to visualize. But yeah, there is a plane, and probably I can, in fact, draw one more plane. Yeah, why not? We can draw one more plane. So maybe, yeah, this color is okay. So let's see if we can actually plot various planes. So can you see the two different planes? Very weird, right? Yeah. And see the plane between the r and the z axis, right? We have two planes. One is the r and the y axis, r and z axis. So which plane is left? What we are missing? The r and the
x-axis.
x-axis, because that is difficult to do it inside. Okay. So let's be happy with these two angles. Okay. So now what we do is, for the sake of, okay, that is also there. The r and x-axis is there. It's somewhere behind actually. So to draw that plane, you have to draw this line first. Maybe I can get a blue line. And probably we can show like this. Means whatever space is left, I can. Okay, so something there, that side is the x-axis. So how to find the angle? So if we have a vector in three-dimensional space, so we have three planes for each axis and the vector. So when you take a vector and one of the axis, it defines one plane. And because we have 3 planes, so the number of planes is equal to number of angles we need. Okay. So how many angles we need? We need 3 angles. One with the x, one with the y, another with the z axis. And there is a very famous name to all of these angles. So we say the angle it makes with the x axis, we say alpha. The angle it makes with the y axis, we say beta. And the angle it makes with the z axis, we say gamma. So how many angles we have? Okay. Now we have many triangles. So I will show you the right angle, how to see the triangle. So this is the right angle. Here, this is the right angle. This is the right angle. And here, this is the right angle. This is difficult to see actually. This is the right angle because it's a diagonal of the right face and the x-axis, which is right angle. Difficult to
Yes.
visualize, but it is there. So you can look at the corner of the room and try to redraw this picture in that corner. Then probably you can realize what I'm trying to say.
So the green and the blue line will
The
meet.
green is with the ceiling of the room, the diagonal which you draw on the ceiling, and the vertical line.
So no, I'm just saying that the green line and the first green line and the blue line sir will make a triangle.
Yeah, correct. Yeah, the green line in the center. Yeah, was the R vector and the okay. I should draw the blue line bold actually. Correct. So the green line and the blue line is making one triangle. So first of all, in 3 dimension, we need to draw 3 different angles. That's the one thing. But before we go for the angle, we also need to understand what is the R, how to write the R vector in terms of the coordinate x, y, and z. So what we do is we make a triangle like this, and we rely on the triangle law only. So there is no other option. So what I'll do, I'll call this as OQ vector. So maybe bold. This is the OQ vector, and then we have the QP vector, and this is again right angle. So in triangle OQP, applying triangle law, applying the triangle law. Can you guys tell me what should I write next? What is the triangle law?
Sir, a square plus b square plus 2ab cos theta.
No, beta, that is not triangle law.
Under
Triangle law, Pythagoras law. Triangle law, vector addition.
Underscore, sorry, under root a square plus b square
Oh no, come on.
plus
So
2ab
you guys don't
cos
remember.
theta.
No. So triangle vector addition is that the vector OQ vector plus QP vector is OP vector. In any triangle, the sum of the 2 vectors is equal to the resultant. That's the idea. Understood? So you guys have totally forgotten the triangle law. That's really bad. So triangle law
Sir,
is
I had a doubt in the same thing. Sir, that sir, can we add 2 vectors without like?
so this is what we are learning. We are adding 2 vectors. Come on.
Sir, directly or under right that? For
No, we are
example,
right. This is the way of writing. What is directly? We are writing in symbols. So OQ vector, because if you look at the triangle OQP, it makes one triangle. And from the definition of vector, if I say this is A, if I say this is B, so A plus B must be R, right? The triangle law says that the sum of the
Yes,
two
sir.
vectors in order will give you the resultant in the reverse order. So which of the two is in order? A and B are in order, right? So if you don't remember, go back to the first lecture, watch the video again, and hopefully you will have the fair idea. So R vector we can write as A plus B, right? Is this clear? No, not clear. Clear.
So clear.
Now, what is next? So OQ is something which you can rewrite. I will see question 1, and then what I'll do is I'll like in triangle, maybe I can write R. So in triangle O R Q, I can write O R. Okay, and let me put the arrow plus RQ equals to OQ because I want to find the OQ as well. So I can say question 2. So now finally OP vector. So from
So
1
there
and
is
2,
R.
pardon, R is here. From 1 and 2, what we can write? I can substitute OQ there. So OP vector is equals to OP vector is equals to, which is very, this is what we're looking for, OQ. OQ we can write replace by OR plus. Now you may be asking, sir, why you have done this? The answer is simple. I want to write the answer in terms of the vectors which are parallel to x-axis or y-axis or z-axis. Because OQ was not parallel to any of them, so I re-expressed in terms of the vectors which are parallel to x, y, or z-axis. Now, if you look carefully, what is OR? OR is exactly equals to xi cap. So can you see the OR is xi cap? So OR is xi cap. What is RQ?
सर आपने क्या बोला अभी वो थोड़ा सा नेटवर्क का इश्यू हो गया था
मैंने बोला
Sir, it is
हाँ
sir, RQ is Z J,
K
K
cap.
cap.
Very good.
Yeah.
K cap.
So what I said is, who is asking this question?
Miss sir I am Parth.
Park, yes, Park. So what I'm saying is that you have to. There is something called triangle law. So because you have not attended the previous lectures, so
Yes,
what we are doing is we are applying the triangle law of vector addition to get the R vector in terms of x, y, and z. That is the
Okay.
purpose of doing all this calculation. So don't worry. I mean, we have. I mean, you will get all lectures which is saved on the internet. So sir will give you the link to revisit those lectures.
Yes, sir. No, sir, I saw that triangle law of vector and
Yes.
parallelogram.
Very good. Very good. So xi cap plus zk cap is the OR plus RQ vector. Now, what is QP vector? Can you guess what is QP vector? Can you see which direction it is pointing?
Sir, it's the J cap. No. J cap.
Yeah, correct. So what is the value?
Sir, but it has Z also, right?
Pardon?
Z and X.
No, no. It is parallel to axis, so it will have only y. The length is y, and the direction is z. So this is y. So this is also y.
Yeah, sir.
Yeah. So if you rearrange properly, it looks like x. So if you look at the final answer, it's very easy. X I cap, Y j cap, and Z k cap. So it is just like if you know the three coordinate, you just put I, J, and K with each coordinate, and you're done. And therefore, every position vector in 3 dimension we can express as the sum of three components x I cap, y j cap, z k cap. And this is very, very important in how to express it. So taking the clue from this derivation, in general, every vector in 3D space can be expressed as sum of its components along x, comma, y, and z axis. What does it mean? Let ax, comma, ay. So again, x, y are subscript, and az or az are three components of a vector A in 3D. Then A vector we can write as simply ax I cap plus ay j cap and az k cap. So depending on the space, you can write a vector in the fashion of sum of its components. Make sure the component is the value, I, j, k is the direction. So you should not get confused with the value and direction. Okay. So when I write, let's say if I write a vector a equals to minus 2 I cap plus 3 j cap minus 5 k cap, then how one should interpret? So I should interpret this as 2 is the value, direction is minus I cap, 3 is the value, direction is j cap, and 5 is the value, direction is minus k cap. So the values must be positive, and the minus and plus sign will only give you the direction. So it means the A vector having 2 unit in the minus x-axis, 3 unit in the positive z-axis, and 5 unit in the minus k, that is the z-axis. So if I want to represent, on a three-dimensional graph, how will it be look like? So let me just do it for the sake of understanding. So I'm not completing the entire cube because that's not the purpose. So now purpose is to represent a vector. So how the a will be? It's a 2 unit in the minus x-axis. So if I say this is x-axis, so I have to draw a minus x-axis. Maybe I will go backward. So maybe you have to move 2 units backward. So maybe something I can say 1. So you are somewhere here. 3 j cap. It means you have to walk 3 units upward. 1, 2, and 3. So we are here. And then you have to walk 5 units minus k cap. So walk behind the wall. 1, 2, 3, 4, but 5. So basically, if I extend this line, this will take a lot of effort. If I extend this line this way, and probably if I extend this line further, okay, it's a really bad example. So how is this vector? This vector is something behind. Okay, so if I draw a perpendicular, this is my cube. Come on, this looks interesting. So my vector is in this cube. And you know how the vector is? Vector is like this. This is your vector. So this is your R vector. Can you see the R vector now?
Sir, yes, I drew it.
This is A vector. You can see. So the idea is when you express a vector in with the help of three components, so you have to move parallel to x, parallel to y, parallel to z, and then you can arrive at the vector. So that's the idea behind the
Sir, I have one
three-dimensional.
question.
Yes.
Sir, like in a Cartesian plane, we have first, second, third, fourth quadrant. Sir, like in the
We
this
have
3D.
8 octants. We have 8 octants. So it's called octants. It's not quadrants. Quadrants means 4, and octants means 8. Okay. So you can you know permutation combination.
Yes, sir.
Sir, little bit.
So
And
we have
yeah.
x, y, z. So I can take plus 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 minus plus minus plus minus plus plus. Okay. So okay. In fact, I should write. That's fine. That's fine. So we all plus. Then we have minus minus. Then we can take 2 minus. So minus minus plus minus plus minus plus minus minus. And then we can take all minus minus minus. Count how many? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 octants. What does it mean? All three x is positive, x, y positive, z negative, x positive. You can think that. So we have 8 octants. So if we have 4, then x, y, z double some in the Einstein world of 4 dimension. Then how many we will have? So you can see it will have 2 power 4. That is 16. Okay, 16 subworld. That's something. So if we have n dimensions, so we will have 2 power n subworld. Oh, that's no, not even correct actually. So I won't say this is correct. Okay, so things will be very complex in the Einstein world of space. I don't know how he did it, but that's genius anyway. So we are layman and he's genius, so we should not compare. I'm removing this because that's find this space unnecessary. Okay. So every vector you can represent like this. Now comes a very obvious question. So how to find the modulus, the magnitude, the length. So the length of a diagonal of a cuboid, I hope you all know.
Yes, sir.
So what is the length of a diagonal of a cuboid? So the length of a diagonal of a cuboid is under root of length square, width square, and height square. Under root.
Yes, I know.
It's like the application of Pythagoras 2 times. So you have to apply Pythagoras 2 times. How and why? Okay, go back to the diagram. You can see it. So before we find the OP length, can you tell me what is the length of OQ? OQ. What is the length of OQ?
Sir, OQ is R square minus Y square under root.
If you look at the bottom triangle, if you look at the bottom triangle, okay, then you can realize that OQ is made of the two sides OR and RQ, which are right angle. So difficult to visualize, but it is there. So I can draw it here. Look at this. So if you look, okay, I mean actually it is like this, but okay, you can top from the top view, you can look this way. So previous page. This is O R. This is right. This is X in length. This is Z in length. If you remember, this is X. This is Z. So what is the length of OQ? That's pretty easy.
Root of x square plus z square.
Yeah, correct. So the value of OQ OQ will be root of x square plus z square. Now, if you know this answer, so if you look at the new triangle, again, this triangle you should visualize more often than ever. So OQ, sorry, so if I do a triangle like this, which is OQ, and okay. So this is my R, this is OQ, which you got the answer, and this is P. So QP is Y, and we know this is under root of x square plus z square. But it is again a Pythagoras. So what is R? So we can write R square equals to y square plus whatever square. That's what we are getting now. So R square equals to y square, x square, z square, and it's pretty easy. So to remember, it's not a big deal. The length of R called the magnitude is simply is sum of square of its component and take the root. So it's the root of sum of square of its component. And what we need to also remember, the negative or the positive will not come, it will be only positive and only positive. And although we have derived for the R vector, but it is true for all vectors. So mod of A we can write as under root of sum of square of component. So component square, square. Okay, so what about this answer? What is mod of A here? What should I write here? Tell me. Under root of. Can you guess, guys? What should I write here?
Sir, oh, sir, it should be minus 2 square.
It's 2 square. See, we don't consider minus plus. We say only take value because value is always positive. 2 square
Plus 3
3
square
square.
plus 5.
And I think you can, this will be 4, 9, 13, 25. How much? 38. I don't know.
38.
Just you can check. So this is the answer. So finding the modulus is very easy. Just square all components, add them together. So it is like the extension of the 2D into 3D. So you just add one extra term and then you are good to go. So that is the idea, okay, in writing a vector like this.
So please, will you show this? Means, sir, I want to note this one.
Okay. So now we are going to come across the most important part of this topic called the direction of a vector in three-dimensional space. So, okay, you can copy it, but okay, I have to move it too quickly.
Sir, I want to note the previous slide, means the last slide.
You want to go the next or the previous?
Next, sir.
This one?
Yeah, sir.
So before we end today's topic, I have to finish this direction cosine, something called.
Done, sir.
Okay. So now we are done with uh, the R value, how to find the length and how to find, now comes the direction. So direction of a vector in 3D. Now this is a very, very important topic from the point of view of mathematics as well. So in the maths, at the end of your syllabus, you will learn the vectors in 3D, and there again you need this concept, and you need it more there actually. So direction of vector in 3 dimension, because as I said, a vector in 3D will make 3 different planes with 3 different axes. And because we have three planes, we need three angles. Now the angles are difficult to calculate, but what is found to be very easy is the cosine of those angles which we are looking for. And as a convention, it is generally expressed as cosine of those angles called alpha, beta, and gamma, and that has brought a name to it called direction cosines. Okay, so the direction cosines is the cosine of the angle that the vector makes with three different axes. Okay, so we define something called direction cosines. In short, we write DCs. And how we write? We write as a triplet of three numbers. The first is called cos alpha, the second is called cos beta, and the cos gamma. These two find like this. So finding the cos alpha, cos beta, cos gamma is much easier compared to finding the alpha, beta, gamma. And why this is so? So actually, I could have shown you how the formula comes for cos alpha, cos beta, cos gamma, but I'll show you one of them. So go back to the previous problem. Yeah. So yes, this you can see. Okay. So look at this problem. So maybe cos beta we can find easily. What is cos beta? Can you guess cos beta? Because that's easy to see, visualize. So what is cos beta? Can you see the triangle in which the beta is actually defined?
So y upon a magnitude of r.
Yeah. Y upon
Y
mod of.
upon mod of like
Correct.
so.
Very good. So that's really nice. You got this answer very quickly. So can you guess the angle cos gamma? Because that's also obvious in the diagram.
Sir, you are not mentioned the abbreviation. I mean,
Gamma is here.
Z, sir, Z,
Yeah.
Z by R.
Z by r.
Very good.
Z by R.
Very good. And I think if you have got the two, the third should not be difficult. What is cos alpha?
X upon r.
Very good. Very good. Very good. So now, okay, you have championed this concept very quickly. So you have saved my time a lot. Thanks a lot for that. So this is x by r, comma, y by r, comma, z by r. And this is something very interesting. What is interesting about this? So I'll go back to the r vector. So we used to write r vector as xi plus yj and z.
ZK.
So if I divide both sides by the modulus of r, because that is also r, so this will become xi, yj, zk, and we divide by r. I'm just writing r because mod is not a nice way of writing. And then I can partition it. So I can write x by r I cap, then y by r j cap, and z by r j cap. And just we realize that the moment we find the unit vector of a given vector, the coefficient of I, j, and k represents the direction cosines. Because this we can rewrite as cos alpha I cap, cos beta j cap by definition. And what is on the left? We have r cap, the r hat, if you remember the unit vector definition. So the moment you divide a vector by its own magnitude, what it becomes? It becomes unit
Its
vector.
length.
Yeah, unit vector. And what is the length of unit vector?
1.
Very good. So now we know the length is 1. So if I take modulus both sides, so r cap modulus will be how much? Mod of cos alpha I cap So what is the meaning of mod? Mod means what is the length? I'm asking the question, what is the length of the vector on the left and vector on the right? So left, so we know it's 1. But how to express the length of vector on the right? So we have just learned that if we have a vector which is expressed as something I, something j, something k. So what is the length? It's under root
Cos square alpha
Cos square alpha plus cos square beta plus cos
beta
square
plus
gamma.
cos square
Very
gamma.
good. So this is one of the very fascinating property that if you add the square of direction cosine, it always add up to 1. So the cos square alpha, and cos square beta, and cos square gamma, if you square both sides, you get to 1. So now this is one of the most important property of direction cosine. The square of the direction cosine always give you 1, the sum of all values. And then similarly, we have formula called direction sine. This is direction cosine. We have direction sine. It's not a big deal. We can convert cos into sine as 1 minus.
Y minus sine square alpha plus.
So I hope you know from the trigonometry. This is something we know. And if you rearrange, it turns out to be
2.
2. Now these are the questions which comes in the examination. So now how to find the DC? Okay, so what kind of question you come across? You will come across questions like this. These are itself question. So now we'll do some practice. So let's say I give you vector, maybe a force is acting 2I cap minus 3J cap. So this is how plus 4. Nice. Now, if you look at this formula, F, so F is oriented somewhere X minus J down and towards me, right? So it's in the some bottom quadrant, octant, sorry. So this force is somewhere here, somewhere down, and somewhere like this. So it is somewhere here, right? Can you imagine the force?
Yes, sir.
And now the question is, what is the meaning of direction cosine? So it means the angle it makes with the x, y, and z axis, right? So to find the angle of cos alpha, cos beta, cos gamma, what I can do? I will divide the vector by its modulus. And the moment I do so, what I'll get? 2i, 3j, and this divided by what? What we should divide by? The mod 2 square, 3 square, and root 3 square. So how much we're getting? Can we simplify the root value? If you add all three, what will you get?
Oh, sir, answer will be 4.
Very good. So the F cap turns out to be 2I cap 3J cap upon 4. F cap you can write as 2 by 4 I cap. Oh, you have to be careful. You have to write the minus inside because the coefficient must be cos. So I have to write minus 3 by 4 J cap. Everything I J by 4.
Some minus j cap, no?
No, here we are not finding the direction. We are finding the direction cosine. Okay. So the cos value can be negative, right? Cos can be positive, cos can be negative. So when you write the angle, if it is obtuse angle, it's negative. That's why the cos is negative. So we write I, J, K separately, and then the entire coefficient is called cos. If you recall how we wrote the answer. So if you look at this answer, can you tell me what is cos alpha? Cos alpha is how much?
Cos alpha. Y upon R.
1 by 2.
No, except 1 hour.
1 by 2. Wherefore, this is cos alpha. Come on.
Cos beta is minus 3 by 4.
Yeah. So cos beta is minus 3 by 4 and cos gamma is root 3 by 4. Hello, Josh.
Then alpha will
Hello,
be
Josh.
inverse of
Give me
that.
some time. Give me maybe I'll 10 to 12 minutes. Okay.
ओके तो फिर मैं 10:45 को ज्वाइन करता हूँ
45. Yes. So now we have the direction question. So how we express it? DC is the triple sign 1 by 2 comma minus 3 by 4 comma. Okay. So this is how we find the direction of any vector. So look at this. Maybe I can say A is to Y is to Z. Find angle made by vector A with X, Y, and Z. The last question. We'll do the rest in next class. So quickly tell me the answer quickly. I don't have time. So what is alpha? What is beta? What is gamma?
Sir, alpha is cos inverse 2 by 3.
Very good. Very good.
Beta is cos inverse minus 2 by 3. And uh, gamma is cos inverse minus 1 by 3.
Correct. So these are the answers.
So please will you show the last screen, please? Okay, sir.
Okay. So now today I'm ending the lecture here only, and I hope you guys learned today about the component, how to take the component vector, and also you learned about direction cosines. Okay. So a vector in 3D requires three angles to be expressed, whereas in a plane, a theta is enough. Okay. So that's a huge difference between the vector in 3 dimension and 2 dimension. So we'll do more problem in the same, and we'll proceed with the topic also in the next lecture. Till then, goodbye and take care.
Thank you, sir.
Bye.
Sir, you will send the whiteboard na in the group.
Yes, I'll send everything.
Yes, sir. Thank you so much.